this is Hassler here. I'm going to be doing the 4.4 practice in case anyone is absent on Friday. And I'm just going to run through the we do problems, and then your job is going to be to mimic those problems for the you do part, and then turn that in. Okay, so the thing that we've been talking about the last day or so is this point slope form. It says, number one, what two items do you need to write the point slope equation for a line? Well, in order to write that equation, I need a point, so an x and a y, and I'm going to say that we also need a slope. And remember, slope is designated by that m value, and just a reminder to find slope, you could do the change in y over the change in x, or use that formula y2 minus y1 divided by x2 minus x1. And then 2 says, what is the general equation for a point slope form of a line? Okay, that's y minus that y coordinate. So I'm going to call that y sub 1. I'll go back over to this point in problem 1 and call that x sub 1, y sub 1. So we know that those pieces go together. Equals m times x minus x sub 1. Again, just to reiterate, I'm going to highlight this point here of this x sub 1 goes right here in the formula for point slope form. And the y sub 1, the ordered pair I'm given, goes right here in the point slope formula. And then the slope is the m, and that is always in front of the parentheses where it says x minus x sub 1. Okay, so again, I'm going to do the we do problems, and then you're going to go back and do the you do problems. It says graph the line using the given information. Then write two equations in point slope form to represent your graph. Okay, so in problem 3, I have 2 points. Okay, here's my first point, 6, 2. Remember, you always start at the origin. I'm going to count 6 on the x-axis and up 2. There's my first ordered pair. And then I have negative 2, negative 2. So again, starting at the origin, I'm going to go left negative 2 and then down 2. Okay? And then I'm going to connect these points with a line. Wow. That's got to be the best line I've ever made. All right, so A says graph the line. Check, I did that. Okay. B says m equals, remember, m is that slope. And yeah, I can use my slope formula to help find that slope. But if I have a graph, I could just count this on my graph. And remember, you can make those slope triangles to help you. Right, I'd have to go up 1, 2, 3, 4. Up 4 is a positive direction. And then to the right, 1, 2, 3, 4, 5, 6, 7, 8. And again, moving to the right is a positive direction. So my slope or my rise over run is 4 over 8. And if I can simplify a fraction, I should do that. All right, equation number 1. So I'm actually going to use this first point of 6, 2 in my slope to fill out that first equation. And what I like to do is I like to fill in that skeleton piece. I'm going to have y minus that y coordinate equals my slope, parentheses, x minus the x coordinate. And then what I'm going to do is I'm going to go fill those pieces in. So y minus the y coordinate. Well, my y coordinate was 2 equals my slope, which was 1/2, times x minus my x coordinate, which was 6. Now I'm going to do the same thing, but I'm going to use the second point. So again, I'm just going to write out that skeleton, that y minus, I got my y coordinate, equals my slope, times x minus that x coordinate. Now I'm going to go and I'm going to fill out this equation based on my second point. Again, just to reiterate, this is my x, this is my y. They both happen to be the same for this problem. So y minus a negative 2 equals my slope, half, times x minus a negative 2. And we talked in class that minus a negative is really a plus, right? What I really have is y plus 2 equals 1/2, parentheses, x plus 2. So we talked in class that when you write this equation out, what ends up happening due to that subtraction is that whatever the coordinate is, so for this particular problem, my x and my y coordinates were negative, they show up as being positive in that equation. And the reason is because I have minus that negative number. So because of the subtraction, I end up with these opposite signs. Similar story for the first point. I had a positive 6 and a positive 2, but they show up as a minus 6 and a minus 2 in my equation due to the fact that my formula has subtraction. All right, I'm going to move on to 5. So again, I have to graph a line using the given information. And this time I'm given a slope of -3 and a point of 1, 2. And I have to plot this first, okay? Plot point first. Right, in order to use this slope, I have to have a point that I started at before I can count that slope, that change in y over change in x. So I have to have a starting point. And my starting point is this 1, 2 that was given. So I'm going to plot that. Starting at the origin, I go right 1, up 2. That's my point 1, 2. My slope just says -3 though, and often a slope is written as a ratio. So you can always write your slope as a number over 1. Now remember, the top number tells you if you're moving up or down. That top number is negative. So from this point right here, I'm going to count down 3. 1, 2, 3. And then since the 1 in the bottom is positive, I'm going to count to the right 1. I'm going to do this a couple of times. So I'm going to count down 3 to the right 1. Down 3 to the right 1. The other thing that I could do, this right here, is equal to saying 3 over -1. It doesn't matter which number is negative. If the fraction's negative, then the negative can go with either of them. So based on the way I wrote that, I could go up 3, but to the left 1. Up 3 and to the left 1. And I'm just going to go ahead and connect those points. Not as nice of a line as my last one, but close. Okay. All right, so I have this initial point here of 1, 2, and it asks for an equation. And so again, I'm going to use that point slope equation. I'm going to say y minus my y coordinate, which was 2, equals my slope, -3, times x minus my x coordinate, which is 1. So I'm just putting these pieces, right, this x, y, I'm putting those pieces directly into my point slope equation. And then it asks for a second point on the graph. Well, got so many to choose from, right? I have 0, 5 that I could choose from. I'll just write that down. I have -1, that -1, 8 that I could choose from. And I have a point down here, right? I could do 2, -1. The options really are many. So your job is just to pick one of those points and again, fill out a point slope equation. And it does not matter which point you choose, okay? I'm going to go ahead and just choose this point right here, this -1, 8. So again, y minus my y coordinate, which is 8, equals my slope of -3 times x minus -1. That's the same as saying x plus 1. Okay? And if I were to graph these two lines, these two would give me the exact same graph. Okay? All right, I'm flipping over to the other side. All right, this time it says, given the graph, write an equation in point slope form using the given point on the graph. Okay, so for 7, I already have a point that's given. So I'm going to go ahead and write out that ordered pair. That looks like -4, 5. And in order to write a point slope equation, I need a point. So we've got that. And I need a slope. And slope, remember, is graphically, we can count that rise over run. Okay, so I have to pick another point though in order to count that slope. And so I have a couple options. Again, I like to pick points that are going perfectly through the intersection of the grid lines. Okay, And then again, I'm going to count my slope by looking at those slope triangles. I have to go down 1, 2, 3. So my slope is -3 over, I go right 1, 2, 3, 4. That's a positive direction. So I have a slope of -3 over 4. And now I'm going to use this information to write a point slope equation. So again, y minus that y coordinate, which is 5, equals my slope, -3/4, times, wrong parenthesis there, x minus -4, so really x plus 4. Okay. Last but not least is problem 9. It says given the line, graph the line given the point slope equation. We're going to graph and we're given a point slope equation. Okay, so again, the information that I can get from a point slope equation is a point. So I have to be able to pick a point out. And the slope, I should be able to pick the slope out. The slope I think is the easiest. This is the end in that point slope equation, and so my slope is -5/3. But again, I can't use my slope until I have at least a point on my graph. So my next job is to pick out the point. Now remember, the number associated with that x is the x coordinate of my point. X comes first in my order there, and it's an opposite sign. That's what we talked about on the front. Because I have this subtraction, right, and because my formula is typically y minus the y coordinate equals the slope x minus the x coordinate, when I go to pick out this x coordinate, I'm focused on just this 4. It says minus the number that is my coordinate, and that problem says minus 4, so my x coordinate is 4. And similar story for the y values. It says y plus 2, but see, my formula has a minus in it. So just a reminder, when we're talking about this formula, this y minus, I would have had to do y minus -2 to turn into this plus 2. So my y coordinate is the opposite of what I see in that equation. My y coordinate is really a -2. And now I'm ready to graph. So I'm going to graph the point 4, -2. Then I'm going to use my slope of -5/3 to get another point. -5 means I'm going to go down 5. 1, 2, 3, 4, 5. A +3 means to the right 3. Or I really could write this as 5/-3. Those two things are equivalent, which means I could go up 5 and to the left 3. Notice that my line is decreasing, and because my line is decreasing, it matches my slope that is negative. All right, so again, your job is to go back and to do the you do column, and then your final job is to answer problems 11 and 12. So we want you to reflect on what you feel most confident on and what you feel the least confident on, so that when you scan that into Google Classroom and we read through these, we can collect some data on what more we need to do to assist you with these problems. As always, if you have questions, just let